All right, so I am on the worksheet that we were working on yesterday because we didn't get a chance to finish it. So I wanted to finish this worksheet and then go over today's material. So this is where we left off. We finished these problems here where we went and found the X-intercept, Y-intercept, slope, and graphed the lines. I wanted to talk about horizontal and vertical lines. Horizontal and vertical lines. Let me label these real quick. Additionally, as a reminder, you do have your test, or just wanted to move these down. You do have your test coming up, opening up on Friday. It'll be available on my lab. So it's open this Friday till next Friday, just something to kind of keep on your radar. All right. So lines with positive slope, if we look at them, if we look at lines that have positive slope, so this number here is positive. Look at the shape of this line. Positive, look at the shape of this line. Positive, shape of the line, compare to negative. All right, this slope was negative. Notice the shape of this line. Slope here, negative, positive. So you can kind of notice that when the slope is positive, the line goes upwards when you move from the left to the right. Whereas negative slopes go downward as you move from the left to the right. That's a horizontal line. This is a vertical line. And now this is really fun when I do this in class because I'm an awful artist and I don't have the niceties of technology. But now that I have technology to help make me a better artist, I'm gonna draw a little car. So the cars I draw in class when I'm doing this without an iPad are not nearly as good as this one. All right. Is it a good car? No, but still the cars look way worse when I'm doing it in person. All right. So for positive slopes, the way I like to think about it is if you're a little car and you're driving from the left to the right, a positive slope has you driving uphill. So an example of a line with positive slope would be something like y equals 2x plus 1. So the slope is 2, so it's positive. And the car drives uphill. On the other hand, if you're driving from the left to the right, the little car drives downhill if you're on a negative slope. So a negative slope would be something like y equals negative 4x plus 2. The slope would be negative 4. And the car would drive downhill, drives down hill, which is all cool and interesting. But potentially more interesting is what happens on horizontal lines and vertical lines. So a horizontal line, the way that horizontal lines look is something like this. Y equals -2. So it's y equals, and then it's a number. There's no x's at all. Here, the car's not driving uphill or downhill. The car's just driving straight on flat ground. So in the case of a horizontal line, the slope is 0. The slope is 0. With vertical lines, we run into a bit of an issue. Tiny bit of an issue in that the car can't even drive on a vertical line. A vertical line is something of the form x equals a number. So there's no y's involved at all. It's x equals a number. And the slope of a vertical line is undefined. Undefined. Because the little car, the little car can't drive on that line at all. So his slope is undefined. That's how I like to remember the difference between slope 0, slope undefined, because the horizontal and vertical lines, they get flip-flopped in people's heads a lot. One way I've had students remember which one is y equals a number and which one is x equals a number is because y is like an upside down h. So h for horizontal. So y is an upside down h. So horizontal lines are y equals a number. And V's are kind of like an unfinished x. So it's x equals a number. Take it or leave it. That's what I have for you. My way of memorizing that. So I'm going to do a few examples with horizontal and vertical lines, but are there any questions on this idea of positive slopes, negative slopes, slope of 0, slope undefined? All good? I appreciate the participation. Thank you. All right. So find the slope and x and y intercepts of the line, then sketch the graph. If we have the line y equals 4, so y equals a number, that's going to be a horizontal line. And it's going to be a horizontal line at y equals 4. So if we go to 4 on the y-axis, it's just going to be a line that covers y equals 4, all of y equals 4. So the x-intercept is where the line crosses the x-axis, but in the case of a horizontal line, unless you're actually sitting on the x-axis itself, so if you were y equals 0, unless you're y equals 0, horizontal lines do not cross the x-axis. So there is no x-intercept. The y-intercept, though, is 4. It's 4. It's 4 everywhere. But at the y-axis, it's 4. So the y-intercept is 4. And then the slope of horizontal lines is 0. On the other hand, if we had a line like x equals -2, if it's x equals a number, that's going to be a vertical line. And we go to the x-axis and we go to -2. And it's going to be a vertical line at -2, at x equals -2. His x-intercept is at -2. He does not cross the y-axis, so he has no y-intercept. And then the slope of a vertical line, remember, little car would fall off. So the slope here is undefined. Can I answer any questions on those two examples? Nope. So far, so good? All good? Excellent. Good. Good. Excellent. So moving on to the next page. For these ones, we have a graph that's given to us. We want to find the x-intercept, the y-intercept, the slope, and the equation. And the equation in slope-intercept form. So for the x-intercept, that's where we cross the x-axis. So the x-intercept is at -2. The y-intercept, where we cross the y-axis, is at 4. To find the slope, we have 2 points on the line, so we can do rise over run. So starting here at our x-intercept, we need to go up 4 units and right 2 units to get to the next point. So rise is 4, run is 2. If we simplify that fraction, the slope is 2. And remember that slope-intercept form, that's y equals mx plus b, where m is the slope and b is the y-intercept. i.e., this guy right here, y-intercept. This guy right here, should have not done pink on pink, but too late for that. Ooh, no, it's not too late for that. Let's do so we have y equals, the slope is 2x plus the y-intercept is 4. Oh no. How do I get that to come back? Where did my... No, come back. There we go. Fixed it. Questions on that example? Does that make sense what you would do for this? You're looking at the intercepts. You can use the intercepts to find your slope, and then putting it into an equation is easy as long as you have a y-intercept and a slope. The next two problems do not have, they're not regular lines. These are going to be horizontal and vertical lines. But I think you have enough information to do the next two, to do this problem and the following one. I want you to try to do those ones. And let me know when you're ready for me to go over them. So in the chat box, when you're ready, when you're done, let me know. Type in done or put emoji, and then I will go over it. But I think you have enough information to do it. Seen a few of those dones come in. Excellent, excellent, excellent. All right. So for this first one here, this is a horizontal line. It does not cross the x-axis, so there is no x-intercept. The y-intercept is at -1. The slope of a horizontal line is 0. And then what's the equation of this line? What do we think the equation of this line should be? That it is, yep, y equals -1. So it's y equals, because remember, horizontal lines, y is like an upside down h, and then y equals whatever number it's on. So it's on -1, so y equals -1. Excellent work. Very similar idea for this next one. The x-intercept is 2. There is no y-intercept. For a vertical line, the slope is undefined. And this time, the equation of a vertical line is going to be x equals, and then it's the number where it is. So it's on 2, so it's x equals 2. Questions on that at all? Did that one go okay? Good, good. Excellent. Good, good, good. All right, last page of examples. These actually go a lot quicker than they look like they're going to go. So for problems like this, where you have a slope and you're passing through a point and you have to graph, this is actually quite fast to do. So you're going to start by plotting this point here. Plotting this point here, and then using the slope to plot your next point. It's the same thing you did when you plotted the intercept and then you plotted another point, but instead of plotting an intercept, you're plotting a point and then using the slope to plot the next one. So I'm plotting the point 4, 2. My slope is 2/3, so that's up 2, right 3. I'm going up 2, right 3, and plotting my next point. If I wanted this to be an even better looking line, I could continue going up 2 over 3, plot another point. And you can even go in the backwards direction here. You could go down to left 3, just kind of following the same pattern, but in the opposite direction, to give yourself the nicest looking graph possible. Close enough. Bam. So I'm going to do this problem. I'm going to do this problem. I'm going to let you do the remaining 4 to practice it. But again, you're plotting the point and then using slope to plot your next point. That's what's going on these problems here. For this one over here, you want to find the equation of the line. So remembering y equals mx plus b, what we need is a slope and a y-intercept. So from this graph, it looks like the y-intercept is clear, right? We can find that y-intercept pretty nicely. The y-intercept is -3. And then we just need the slope. Now, it looks like we cross the grid again right here. So it's not, the graph isn't really telling you exactly where they cross, where the points are, but you can tell where they cross on the grid. And those are the points you're looking for. So to go from my first point to my second point, I need to go up 3 and then right 1. So the slope is going to be rise over run, 3 over 1, which is just 3. So my equation is y equals, our m is 3, and then our y-intercept is -3. Y equals 3x minus 3. So not so bad, right? It's not super bad. I want you to try the remaining 4 problems on this page. And then I will, I think what I'll do is actually, I'll just kind of slowly fill out. Yeah, I think that's what I'll do. I'll slowly fill this out as you're working, but I'll put myself on mute. So you can look up at the screen and check your work, but I want you thinking about it on your own. If you have questions, put them in the chat box. do have all the answers up at this point. How are we feeling about these problems? Are we still working through them? Do we need a little more time? How are our answers looking? Any questions on how I got mine? Good, excellent, excellent. Looks good, feel good, excellent, love that, love it. So these are kind of problems that I think look scarier than they actually are. If you have the right tools to do these problems, they can be quite quick. So if you are still working on this, you might want to grab your phone and take a photo because I am going to go to another page. So this is going to disappear in a second. If you have a phone, if you want to take your phone out, take a photo so you can finish copying it down. Any questions at all on any of the stuff on this worksheet before we talk about other line stuff not on the worksheet? All good? Good, good, good. Excellent. Excellent, excellent. All right. So let's move on to lines, day 2. I changed my color because I was doing purple for my headers, but trying out a new color today, seeing if I like this like blue-gray color. All right. Lines day 2. So today's a lot less graphing and a lot more algebra. That doesn't mean it's bad or even that hard. It's just there's a lot more algebra today. So we've talked about finding the slope of a line when we're looking at it on a graph, but maybe we ask a question, can we find the slope of a line without looking at a graph? Can I get 2 points and find the slope between them without graphing? Can I find slope between 2 points without graphing? And the answer is absolutely yes. We have a formula for that. And I was going to talk about deriving the formula, and then I've decided I'm not going to. I'm just going to give you the formula for this one. So the formula between the slope for the slope between 2 points, if you have the points x1, y1 and x2, y2, sort of like we did with the distance formula, the slope between those 2 points is going to be y2 minus y1 over x2 minus x1. This is actually just rise and run. So y2 minus y1, that's the change in y values, that's the rise. And x2 minus x1 is the change in x values. Which is the run. So this is rise over run, but it's a formula instead of looking at it on the graph. Let's do some examples. So let's say we have the points 5, 2, and 4, -3. It does not matter which point you choose to be x1, y1, and x2, y2. So I'm going to do it both ways to show you that it comes out the same way. So if we chose 5, 2 to be x1, y1, and 4, -3 to be x2, y2, then the slope, y2 minus y1 over x2 minus x1, y2 is -3, y1 is 2, x2 is 4, and x1 is 5. So we have -5 over -1, which is +5. On the other hand, if I flopped it and I did 4, -3 as being x1, y1, and 5, 2 as x2, y2, and did the same exact thing, so this would be 2 minus y1 is -3, x2 is 5, x1 is 4, and then 2 minus -3 is 2 plus 3, so that's going to be 5, and then 5 minus 4 is 1. It comes out to be 5. So both ways, regardless of which one you choose to be the first point, you're going to get the same slope. If you did it on a grid, we did this on a grid, so the point 4, 1, 2, 3, 4, -3 right here, and then the point 5, 2. And there's a question, and that works for every problem / number combos. Yeah, so any points, if you have 2 points, it doesn't matter what those points are. When you're finding the slope between them, you can always use either one first. So it doesn't matter with the points, which one is x1, y1, and which one is x2, y2. The thing you want to be careful about, the thing where people will go wrong on this, you don't want to accidentally do x1, y2, and x2, y1. So you want to make sure the 2s are together and the 1s are together. But other than that, it'll always work. But yeah. So then here, if I'm looking, I would go up 5 units, and I would go right 1 unit. So you would get slope equal to rise is 5, run is 1. So you get 5, which is exactly what we got when we did the formula. Questions on that one before I give you one to try on your own? And if not, I'm going to go ahead and scroll down. So let's do -1, 4, and 3, -8. I'm definitely going to try and memorize this formula. Yes, you really should memorize the slope formula. The slope formula is really, really important, and you do want it memorized. Obviously, you could write it down and use it on the test, but memorizing it's going to be a lot better for you in the long run. A lot of formulas are like that. Some formulas are silly, but there's a lot of formulas that are just good to know. All right, try this one out. When you have the slope on this, go ahead and type it into the chat box so I know you're done. And if it's a fraction, make sure you reduce it all the way, simplify it completely. I definitely used the wrong point based on my own notes. I definitely took the point from the next problem. This was supposed to be, the second point was supposed to be 8, -2. Oh well, it doesn't matter. It'll work just fine with this. My bad for not looking at my notes more closely. I mean, it'll be fine. It'll be fine. I just don't know what the answer is off the top of my head. Are we getting answers for this one? I see one person has put an answer in. Okay. So slope y2 minus y1 over x2 minus x1. I'm going to do x1, y1, x2, y2. So this is -8 minus y1 is 4 all over x2 is 3 minus x1 is -1. So that's -12 over 3 plus 1 is 4, which brings us to -3 as an answer. So you should be getting -3 as the answer for that one. Is that okay? Okay. Cool, cool, cool. So there's a few problems on your homework to have you doing that. Now, there's some weird stuff that can happen. And let's talk about it. This is the problem that was supposed to have 3, -8 on it. All right, so let's try this. -7, -8, and 3, -8. And once again, my formula, y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So we have -8 minus -8. And then on the bottom, we have 3 minus -7. So this guy right here, this is going to be -8 plus 8, which will be 0. So you'll have 0 over 3 plus 7 is 10. But 0 over anything is just 0, which is fine. The slope on this guy is 0. But that means something special. If the slope is 0, what kind of line is this? The horizontal line. Absolutely. So if I like draw a really crappy graph right here, let's say this is -8 right here. I have -7, -8. That would be like somewhere out here. And then we have 3, -8, which would be somewhere over here. And that's that is a horizontal line. So not super weird, but a little weird. Another weird thing that could happen. We have 4, -1, and 4, 3. Yes, I am writing down the formula each time. I am doing that to force you to write down the formula each time, because the more times you write it down, the more it will stick in your head. All right, so y2 is 3 minus y1 is -1. Y2 is, or x2 is 4, x1 is 4. So we get 3 plus 1 is 4 on the top and 0 on the bottom. And that's an uh-oh. Because 0 on the bottom, we can't divide by 0, right? We can't do that. It's undefined. Yes, exactly. So this is an undefined slope, which means it is a what type of line? Vertical. Absolutely. Beautiful, beautiful. So sort of like I did with the other one, if I had 4 over here, we have the point 4, -1, which would be like somewhere down here. And then the point 4, 3, which would be somewhere up here. And together they would make a vertical line. The kind of big takeaway there is if your slope is equal to 0 over a number, that means your slope is equal to 0, i.e. you have a horizontal line. If your slope is equal to a number over 0, then your slope is undefined. And you have a vertical line. If you're using your calculator to do these problems, you'll know that you have an undefined slope because your calculator will say something like math error. Math error is the calculator's way of saying that something is undefined. Either you're trying to like take the square root of a negative number, or you're dividing by 0. It'll say math error. If your calculator ever says syntax error, so your calculator says math error, that means undefined. There's 2 different types of errors your calculator will give you though. If your calculator says syntax error, this means you entered it in wrong and it doesn't know how to read it at all. Just some kind of important calculator information. All right. Let's do an example that kind of puts everything together. We're going to put everything together. All right. So this is a type of line problem that is very, very typical. This is like a classical line problem. You're given 2 points and you need to find the equation of the line that passes through that. So this is going to be y equals mx plus b that we're looking for here. The process is pretty straightforward. So your first step 1, is finding the slope, because we need to, just got water on my screen. We need to find m and we need to find b. So to find m, well, we have 2 points. We have a slope formula, so we'll do that. So m is equal to y2 minus y1 over x2 minus x1. x1, y1, x2, y2. So we have -5 minus 2 over 3 minus 1. So -7 over 2. That is our slope. So if we plugged it in right now, what we'd have is y equals -7/2 x plus b. So we still need the b. In order to find b, we can take one of these 2 points and plug it in to this equation, because we can plug in an x and a y, and then we can solve for b. Y equals mx plus b. Once again, our m was -7/2. And it doesn't matter which point you choose. You can choose this point or this point, and you're going to get the same answer. Now, I personally would rather avoid negatives when possible. So if one of my points doesn't have negatives and the other one does, I'm going to choose the points that are positive. If one of my points has a 0 in it, I'm going to choose that one because 0 is easier to deal with than a number. So like there's easier choices, but it doesn't matter which one you choose. You're going to end up with the same answer. I'm going to choose 1, 2 as the point that I deal with. So we have the point 1, 2, which gives us an x and a y. So our x is 1 and our y is 2. So we're plugging in our m. We have x equals 1. We're going to plug that in for this x here. And then plugging in y equals 2. So 2 is equal to, our m is -7/2. X is 1 plus b. So this is 2 equals -7/2 plus b. This would be a great opportunity for using your calculator. So you want to get b by itself, so you're adding 7/2 to both sides. Right? So on your calculator, you can do 2 plus 7/2, or if you looked at how to add fractions by hand, if you looked at those videos and took time to study that, this one's going to be 11/2. I'm not going to talk about how you get it. If you want to know how to add fractions by hand, there's videos. Otherwise, use your calculator. So you get 11/2 is equal to b. B equals 11/2. The last step, now that you have b and m, you just plug them into y equals mx plus b. One place where I've seen people go wrong on tests, especially like in-person tests, is they'll do all the work, they'll get down to here, they'll get B, and then they'll just stop here. Right? So stopping right here is not giving an answer because we wanted a line as an answer. So you have all the components of a line, but you haven't put it all together. So make sure you're doing the full thing and doing y equals, our m is -7/2. And then b is 11/2. And that's our full answer. I anticipate there may be some questions, but you might not know what they are until you've tried it on your own. So I'm going to give you one. To try on your own to see if you have any questions. When you've completed it, go ahead and either if I'd like for you to put your answer in the chat box. If you're feeling really unconfident about your answer, though, you can just put done in the chat box, but let me know when you're done. So you want to find the slope. Once you found the slope, you're going to plug in the slope and one of the points to find B. And then once you have M and B, you plug it into y equals mx plus b, and you get your final answer. Zoom out so you can see everything. So give it a try. Let me know when you're ready. I'm seeing one person done. I do want to start at least working on the answer in like one more minute. One more done in there. I'm going to start working through it. So we're starting with slope y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So we have -5 minus -2 all over 8 minus -4. So -5 plus 2 is -3. 8 plus 4 is 12. This will simplify down to -1/4. So our slope is -1/4. It does not matter which point you use here. I like this one since only one of them is negative. It doesn't matter though. So I'm going to use x equal to 8 and y equal to -5 because I am using this point. Y equals mx plus b. We have -5 equals -1/4 times 8 plus b. -1/4 times 8 is -2. Adding 2 to both sides. We get -3 equal to b. So altogether, we have y equals -1/4 x minus 3. Did that go? Okay. And then there's a question, how do you know to use 8, -5? You don't have to. So you could also use -4 and -2. And you would have -2 equals -1/4 times -4 plus b. -1/4 times -4 is +1. And then you would subtract 1 on both sides. And you'd get -3 equal to b. So either way, you're going to get -3. Does that make sense? Nope, it doesn't matter. Not at all. Not at all. Excellent. Excellent. All right. No problem. No problem. So we talked about the slope-intercept form of the line, which is y equals mx plus b, but there are other forms of the line. And the only other one that I think is important is point slope form. Point slope form. Point slope form is actually nice. Now it's gonna look weird. The point slope form is actually really, really nice because it gives us a different way of finding the slope-intercept form. So it's kind of like an intermediate form oftentimes. It's you go to point slope form and then you change it into y-intercept to slope-intercept form. It's going to look gross, but I promise it'll be okay. So point slope form is y minus y1 equals m times x minus x1, where m is once again the slope and x1, y1 is a point on the line. And I'm going to do an example so that you can see that it's not as gross as it looks. I think I've seen this before. Yep, you probably have. It's probably tucked away in there somewhere. So when you're asked to find the point slope form of the line, that means you stop once you're in point slope form. You don't need to go any further. So here's what it looks like. We have a slope and we have a point. So slope is 3, which means m is 3. This is our point x1, y1. So x1 is 2 and y1 is -5. Our formula is y minus y1 equals m times x minus x1. So y minus y1 is -5 equals m is 3, x minus x1 is 2. So when you're plugging in, notice you still have x's and y's around. It's unlike what we were doing before where you had to solve for b. It is unlike that. So the only simplifying you have to do here is if you have y minus -5, that should be a +5. And then you would just leave it like this. This is in point slope form. That's your answer. Oftentimes, we take it and we go a step further and we put it into slope-intercept. This problem didn't ask us to, but oftentimes we do. So I want to talk about what that looks like. So the way that looks, you're just solving for y. So you would start by distributing the 3. Y plus 5 is equal to 3x minus 6. Then to get y by itself, you'll just subtract 5 on both sides. You have y equals 3x minus 11. I'm going to move into the next example because I want to make sure I get through this before class ends. Normally I would ask for questions, but I want to make sure I get through it. So for our next example, if you do have questions, feel free to type them in. I'm just not going to sit and wait for them. We're going to do a similar one that we just did. So we just did a problem like this, right, where we found the line passing through 2 points. But this time, instead of putting our answer in slope-intercept form, we're going to have it in point slope form. Once again, our first step is the same, though. We need to find slope. So y2 minus y1 over x2 minus x1. So y2 is -2, y1 is 10, x2 is -6, x1 is -2. -2 minus 10 is -12. -6 plus 2 is -4. So my slope is +3. And we have y minus y1 equals m times x minus x1. And we have 2 possible answers because we have 2 different points that we used. I'm just going to pull these down to the next page. So we could use the first point, negative 2, 10. If we did that, we know m is 3, then x1 would be negative 2, and y1 would be 10. So y minus y1 is 10 equals m is 3, and then x minus negative 2. The only simplifying you have to do is if you have a minus negative either here or here, you want to simplify that to a plus. So this would be x plus 2. If you used the other point, if you use the point negative 6, negative 2, then m is still 3, your x1 would be negative 6, and your y1 would be negative 2. You'd have y minus negative 2 equals 3 times x minus negative 6. That simplifies to y plus 2 equals 3 times x plus 6. And you might say, well, those look like very, very different answers. How can you get different answers? So while they look different, these are different looking answers, they actually turn out to be the exact same thing. So if I put this into slope-intercept form, so I distribute the 3, y minus 10 equals 3x plus 6, and I add 10 to both sides. We get y equals 3x plus 16. Over here, I'm going to do the same thing. Y plus 2 equals 3 times x plus 6. Distribute the 3. Y plus 2 equals 3x plus 18. Subtract 2 on both sides. Y equals 3x plus 16. So you have the same slope-intercept form. So these are the same line. They just look different. I'm going to do 2 more problems. I am probably going to go over. I normally don't go over. I'm probably going to go over by a few minutes. If you need to leave at 12:20, I understand, but I do want to make sure I get these examples on here. So I'm going to go through them. So I have just 2 more examples to do. It's really important when you're doing questions to read which form they want the line in. Because if a question asks for point slope form, it's not going to accept a slope-intercept answer. Okay, so let's say we're asked to find the slope-intercept form of a line, and we're given the slope and the X-intercept, not the Y-intercept, because if we were given the Y-intercept, we could go straight away. But let's say we have the slope and the X-intercept. So the slope would be m, so m is equal to negative 2/3. And the X-intercept, remember, X-intercepts are when y is equal to 0. So this is the point negative 6, 0. I'm going to plug this into my point slope formula. So y minus y1 equals m times x minus x1. We have y minus 0 equals negative 2/3 x minus negative 6. The answer wants it in, they want the answer in slope-intercept form. So I'm going to continue simplifying this. We have y equals negative 2/3 x plus 6. We're going to distribute. Then we get y equals negative 2/3 x. And then 2/3 times 6, you could do that in your calculator. That's going to be minus 4. You could alternatively have not used point slope form. You could have alternatively, at this point right here, done y equals mx plus b, and then figured out the y-intercept using the tactics we used before. One last example, X-intercept 4 and Y-intercept -1. So say you're given an X-intercept and a Y-intercept, and you want to find the slope-intercept form of the line. So X-intercepts are when Y is 0. So this is the point 4, 0. And Y-intercepts happen when X is 0. So this is the point 0, -1. So we have x1, y1, x2, y2. And we can start with finding the slope. So we have -1 minus 0 over 0 minus 4. So -1 over -4, positive 1/4. It doesn't matter which point you choose if you want to put it into point slope form first. I'm going to go ahead and use this point here. So we know x1 is 4, y1 is 0, and then m is 1/4. Y minus y1 equals m times x minus x1. Y minus 0 equals 1/4 times x minus 4. Distributing the 1/4. We get y equals 1/4 x, and then 1/4 times 4 is just 1. So 1/4 x minus 1. You would get the same answer if you used the other point. So if you used this point here and you did x1 is 0, y1 is -1, and m is 1/4, you would have y minus -1 is equal to 1/4 times x minus 0. So y plus 1 equals 1/4 x minus 1 minus 1. Y equals 1/4 x minus 1. So it's the same either way, just different ways of getting there. Okay, sorry I went over. Normally don't do that. Sorry I kind of had to rush at the end there. I just want to make sure I got through all those examples. So we just have one more day of material for test 1. So everything up through tomorrow's material is going to be covered on the test. Again, opens Friday. It'll be open until next Friday. You have 3 attempts at it. Your best attempt is the score that counts. If you have questions, go ahead and you can stick around and ask them. Otherwise, I'm going to stop the recording and I will see you guys tomorrow.